Yep. So, are you able to hear me and see the slides? Yes or no? Please, can you reply, friends? Are you able to see these slides that I'm showing you guys? And are you able to hear me? We have also enabled it YouTube Live, and people will be joining on YouTube Live as well. We shall. Yeah. Okay. So, session will start at 5 p.m. Okay, we'll wait for people to join and then we'll get started. Today is the last day of our FTP program and we'll conclude. I will be on mute until then. Okay, I think we should get started. Hello, everyone, and welcome to the session. And we have covered a lot of ground as part of our Auto ML training and machine learning on cloud, Auto ML and ML on cloud. On the first day and second day, we spent some time on what is Auto ML, how to build Auto ML using open source libraries such as Teapot. And then next, we got started with ML on cloud, wherein we covered all the three major players. We started off with Amazon, and then we discussed SageMaker, Amazon SageMaker Autopilot. Then Sharath has walked you guys through Microsoft Azure ML Studio. In that, he explained you about Designer. Then GCP, Google Cloud Platform. Today, we will understand explainable AI and then we'll wind up the session. So let's proceed further. So friends, explainable AI was introduced to the world with the objective that even a person who is non-AI expert or a person who is not a data scientist, a layperson should also be able to understand how the model is being built and how did the model come up with a specific output. And it started way back in 1940, and people introduced something called as Turing machine back then. And today in the in this specific name, they have Turing Awards. What happens in Turing Awards is there will be a competition wherein on one side you'll be there, person who is participating in the competition, and on another side you'll have two things. You'll have a bot and also you'll have a human. And when you send a message here, either the message as a reply would come from bot or it would come from this human. And you should be able to understand where you got the reply from. Did you get the reply from the bot or did you get the reply from the human? You should be able to make out that. Okay. Now, without explainable AI, you can still build a model, but people who are using it, end users, for example, doctors, they cannot trust it. First thing, if you just say that, do you know what? Here is the X-ray image of a person or DICOM image of a person. And my model has predicted that given this X-ray image, by analyzing this, the model has predicted that person has cancer. First of all, doctor doesn't even trust because directly it is giving that output. How are you able to say that the patient whose X-ray is this has cancer? Doctor cannot even understand the output because output will be some numbers, right? That there is 90% probability, so on and so forth. And end user cannot control the process on what's happening, how the algorithm is running. There is absolutely no control. If you can bring in these three aspects, then people can start trusting the end users. They will start understanding how results were obtained and user can control the process. There are two ways of doing it. Okay. One is, say I'll take another example so that you understand. Say there is a shopping mall and this shopping mall wants to using CCTV footages, understand how many people have visited their shopping mall every day, every hour. So the moment a human enters the shopping mall, it will detect that this is a human and it will keep recording how many people have entered. Now, suppose there is one model, model one. Okay. And this model one is highlighting the hand portion of the human and classifying that this is a human. Assume. And say there is another model, which is model 2, which is highlighting the face portion of the human and classifying that this is human. Obviously, people who look at these two models will start trusting more on model 2. They will start trusting more if you can probably overlay a heat map on top of this image, and this heat map will highlight that portion of the image which your model is selecting before making decisions on whether that's a human or not. And this is called as GradCAM, Gradient Class Activation Map. This is one way of bringing in explainability into your model. But then we from our side would be discussing how we can use a specific algorithm called KNN and how we can make use of plain English plus additional information to be able to give more meaningful information to the end user who is going to use the model. Okay, and the business problem that we will be solving here is a disease called as West Nile disease. But then that aside, think about this disease as a disease which is similar to swine flu. Okay, so we are going to build a model first to classify whether a patient has swine flu or not. Whether the patient is tested positive for swine flu or negative. Okay, post that, if I give this kind of a model which just gives the output in this way, doctors might not rely on this. So for doctors to start believing that this is a system which works, we are going to make use of explainable AI using simple English language and some additional information. We'll not take this route of GradCAM because this is more for images. So once again, since we are talking about machine learning on cloud, we would proceed further with Google Colab. So let me show you Google Colab. And when you use Google Colab, I just type Google Colab. Okay. And I'll be clicking on this. I'll just say cancel. For you all, when you open this for the first time, this is how it appears. But of course, you have to log in with some account. I already logged in with my account, so I'm able to see this. And do you see the plus sign here? You can just click on that. And here you see code. You can type 1 plus 1. And when you click on run, it is connecting, and Google will allocate one of the available computers on cloud for you. So you need not have a powerful computer. Okay, so it's connected and it's giving you the result as 2. But what we will do is, I'll go to File, I'll click on New Notebook. When you click on New Notebook, it would open a new notebook for you. the way it's going to appear on the screen now. Come on. Yep, there we go. You give an appropriate meme. If you're working on explainable AI, maybe you'll say explainable AI. But Python notebook. You can give some name. And what you can do now is, after you create this, click on runtime and click on change runtime type. When you click on change runtime type, here in hardware accelerator, in the drop down, you can select GPU or TPU. GPU stands for graphical processing unit, which is at least, I would say, 20-30 times faster than your CPUs. And you have TPUs, which people say are at least 10 times faster than GPUs. And TPU is something which is exclusively, that exclusively belongs to Google. Okay, so let me select GPU and let me save. Once this is done, you can click on connect here. The moment you click on connect, Google is going to allocate to you one of the available GPU machines because you are using the free service. If you upgrade it to the paid service, then you can choose your RAM, etc., and it will be a touch faster. So let me run it. What's going on? Done. So some RAM and some hard disk is allocated. If you see there, 12.69 GB RAM and hard disk space is 38.92 GB. Okay, and it's a Python 3 Google compute engine backend is GPU. It's given to you guys, right? So there we go. So here you can type 1 + 1 and click on run. It says it's 2. If you want to add another line of code, either you can click on this code, or when you hover your mouse on this, you'll see an additional option or two pop-ups, right? Two options, two buttons. You click on that code and you can type here 5 multiplied by 6, for example. And if you click on run, it says that it's 30. And the amount of time it has taken to run the code, 0 seconds. The time also appears. I mean, it took just millisecond to complete. You can also delete whatever is the output, that is clear the output. You can delete the entire line of code. You can do all those things. Right? Simply put, this is where you can write your Python code. So even if your computer is Pentium 3, Pentium 4, i3, a CPU without GPUs, and if you need GPU machine, you can as well use this because this is a browser-based application. Yeah. So let me go to explainable AI code. Rather than I type right from scratch, I have this readily available with me. I would not walk you guys through code line by line. However, I'm going to, let me remove all these things. However, I'm going to, run this entire thing and then explain you on what kind of explainability you will bring into the physician or the doctor. Okay, that's the whole idea here. Remove this. All right, so let's run this code. So all you need to do is, this is the code which I've already made available. And friends, one more thing. This session is faculty development program for through task. And what we will do is, we will look at your attendance tracker, and whoever has given attendance, you will receive an email from us email from 360 digital within 1 week. Okay, and we are going to give you access to all this code, access to the code data sets would be provided to you, and we will also issue you guys certificate of participation. Okay, you'll also receive a call and email from us. All right, and we will ask you to follow certain steps, and then we will also collect feedback. We'll tell you where you can give your feedback. Usually it will be on Google. So we will collect feedback from you. And then we will provide you access to all these things for a certain number of days, maybe 3 months or so. And yeah, you can make best use of it. You can also download the certificate through the access that we provide to a specific system. Okay, we'll explain those things and we will separately send email. We'll follow up with you. This entire process will take a week or so. I'm telling you about these things upfront because I don't want anyone to miss out at the last moment. Okay, all good. Any questions? Important? Not really. Fine. So until now, I have to tell you that there are 736 unique people who have registered through our webinar jam link. While live, there'll be less number of people because certain number of people connect on YouTube live as well. Okay, so back to our explainable AI. So we are importing the required libraries. I'll be a little fast because, okay, let me click on manage. So you can run only one session. Earlier, Google used to allow a permit to run multiple sessions in parallel. You import all the libraries, and within your Google Drive itself, you can place all the data sets. So if you click on this, it's importing, let it import. Once it imports, yeah, done. And when you click on this folder icon, it shows you that Drive is mounted. That means your Drive, your Google Drive. For that, you just need to click on this icon. It's already clicked. Already it is enabled. So in this drive, you'll have all the files. So my drive is my Google Drive in which I have all the files, explainable AI. In this, I have the files. So if you want to copy this path, just do a drop down on those 3 dotted lines. When you hover your mouse on that, you see 3 dotted lines, click on that, copy the path, and you paste the path. And that is this path that you're seeing there. So you can place all your data sets that you need for your analysis on Google Drive and proceed further. Click on this. Drive is loaded. This data set is loaded. And then you're segregating the inputs and outputs. And then this is how the data looks like. Color sputum. When you cough, you get sputum, right? And this is given a range of 0 to 9.9 or 0 to 10. 10 means you have extreme cough, extreme sputum color cough. Then when you cough, you get sputum, you spit it out, right? That's sputum. Cough is, what is the intensity of cough? This is also measured in the range of 0 to 10. 10 means very, very severe. Fever also 0 to 10. 10 means extremely high fever. Headache also is measured on 0 to 10. Given these 4 inputs, what is the output going to be? Would the patient have flu? Would the patient have cold? Would the patient have pneumonia? Or would the patient have swine flu? Swine flu is dangerous. So doctor will, by looking at, or he will ask you, "Hey, how many times are you getting sputum?" Okay, he might collect the sample. He'll understand about cough and fever and headache from you. Fever they'll measure using thermometer, but then headache and cough he'll ask you, "Hey, do you have cough? How severe is that? Do you have headache? How severe is that?" And based on those numbers, doctors will predict. In their mind they predict that, okay, this guy might have swine flu, or this guy might have flu, or this guy might have cold. But that's all assumption, right? So here what we are doing is we are building an algorithm, KNN algorithm, which will not just build the algorithm, but it will also generate a plot for our doctors to see. So if I run this is the kind of plot which will appear. It's saying that for, if this color sputum is 1, cough is 3, fever is 7, headache is 5. Remember, these things are measured on a scale of 0 to 10, 10 being very high. 0 means you don't have any. So if some patient has color sputum of 1, color cough 3, fever 7, and headache 5, your model is predicting that patient has flu. And it's also giving a visualization. But doctor might think that, hey, directly you're saying prediction is flu. I don't believe this. Now you're adding more information for doctor to believe that your system is good. These are all a few of the other libraries which are needed. And these are the libraries, my dear friends, which are used for visualization. So I'm installing it from GitHub. GitHub is a place where a lot of developers keep their code and libraries and many things. So you're directly pulling it from there and downloading it. It's a very big file. If you see here, it's 132.4 MB until now. So it's a big file. That's okay. To an error. So I need to get this base map stuff from another GitHub repository. Certain repositories will become old, so it will throw error. That's okay. That's how it is, because it is open source. No one will maintain the latest version, remove the old version and all that. We cannot expect, because it's open source. Let it complete, and as soon as it completes, I am going to run the other piece of code and then explain. Okay, while it runs, what are we doing now? With simple prediction, doctor is not believing us with this visualization. So you're adding more information. You're taking something called as location history of the patient. Now, hey, where do I get this location history? How do I get this location history? That might be your question, right? Absolutely. So let me show you. If I go to Google location history, yeah, typed it incorrectly. It's okay. Okay, here we have the location history. I just typed Google location history, it's showing here. And you have location history here. We should be able to download it once again. Okay, so there is another URL. Let me type it here. takeout.google.com. takeout.google.com and /settings/takeout. This will let you take out the data from your Google. It will let you download certain things. So I'll first of all do one thing. I'll deselect everything, and then I'll select only location service. Here we have location history. I'll select that. You can actually download this in multiple formats. So I'll just click on next step here. Okay. It says that you can download in zip format, and up to 50 GB of data you can export. You can download location history. If you enable this, Google will track you where all you have traveled, which are the various locations you have actually traveled. And this information should be downloaded with user consent. Data privacy issues come into picture otherwise. Until and unless your patient, the patient whose details are given to us here, what details were given? We are given details of a patient who has colosputum 1, cough 3, fever is 7, headache is 5. This particular patient, for this particular patient, a model is predicting that this patient might have flu. Is it regular flu or swine flu? Or is it COVID? Oh my God, it can be life-threatening. So you are bringing in more information. You will ask this patient, we want to do additional tests. We want access to your Google history. And in most of the cases, it will be by default enabled. After you install, you will have to restart the kernel. That's absolutely fine. So what we are doing is, we have downloaded this location history.json file of that particular patient, and we will load that. Say user has given you access. You have gone to this takeout.google.com and you have created a download file. You have 123,143 rows in the location history dataset. So every day data is tracked. Every hour, every minute, wherever you travel, the data gets captured. This data you want to give, it has latitude, longitude, timestamp, when, where that person was. You're doing some pre-processing, and then you're giving some different color to land and all the other locations. This is all pre-processing, friends. I'll not explain in depth because not needed. So here it says that this patient has traveled in all these locations. Okay, can we zoom that? Can we zoom in? Let's zoom in. Yeah, we have zoomed in. When we zoom in, we understand that this patient has traveled across France, this is UK, across France. And now, on what days was this patient in France? On those days, is it winter season where mosquitoes are more? If it's winter season, then you can tell to doctor that, doctor, you know what, this guy was in France in winter season, so mosquitoes would be more. Maybe he has swine flu. You'll have to relook. Okay, and then you add this data also. Did the person travel to France? Did the person travel to Chicago? Which season was it? How many days did that person spend? And would that give you additional information? Sure, it would. And then you're adding those things and building your model. Okay, and then you're doing the predictions. Prediction says now bad flu. Doctor is confused. Doctor is like, oh my God. Initially you told flu. The moment you added location history, where that person traveled, etc., your model is telling bad flu. Oh no, I won't believe. This is where you give him English language sentences to give a complete explanation about what has happened in your model until now. So you'll give these kind of alerts. So prediction is bad flu, doctor. So further urgent information might be required. Activate the explainable AI interface. Doctor is like, okay, now things are getting interesting. So let me activate. And then you show this visualization. You say, hey, doctor, see, look at this. And for a patient, if fever is greater than 5, if some flu or number of days that the patient has spent in any of the location is more than 4, so on and so forth. This is the output. Your patient has high fever. Your patient has had a high fever for more than 4 days, even with medication. It is probable that your patient was not in contact with the virus in France because it was summer season maybe. It is probable that your patient was in contact with a virus in Chicago. You are giving all these things here. It's all hard-coded. Okay. Your patient is part of explainable AI program that you have signed in. Through authorization, we got access to Google history. And because of this, we feel that your patient might have these diseases. But then you'll give some additional information also. You'll say that, hey, here is another map which says that your patient was also in Chicago, not just in France, but during that period while he was in Chicago, there were some positive detections of a special kind of mosquito, and maybe your patient got in touch with that specific virus. So you have to do some additional test, and you can continue to read more about that specific virus. I told swine flu, right? Think about this as swine flu. The moment you give this additional information to your doctor is like, wow, okay, he'll start relying on your model. But if you just give some numbers, prediction results, etc., doctor is like, hey, come on, I don't want to believe your model, or I don't want to use it. Doctor might feel. So remember one thing, friends, explainability does not just mean you bring in explainability or you're explaining the model output alone. Model inputs, where are you getting, how are you getting, how are you building the model, what is the output looking like, right? What are the accountability requirements? What are the events that occur while your AI model is used in the production? For all of these things, there has to be explainability. For example, you know what? Suppose your server is down. When I say server, say messaging server. Say you're working with Infosys, and Infosys employees communicate over emails. They don't communicate over Gmail, right? They have their own messaging system. That if that server goes down, none of the Infosys employees can send email or receive emails. So these kind of issues would be called as priority one incidents, meaning it should be resolved in 30 minutes. There'll be strict SLA or resolved within 15 minutes in that way. Now, explainability should be there on what inputs you have taken to predict whether these kind of issues will be resolved in 30 minutes or not. Explainability should be given on how people have built the model. Explainability should be there in what is the output everywhere. And also in production, there should be explainability. Because what happens usually is, say Infosys outsourced to Microsoft. Say Infosys is using Microsoft Outlook. So they will tell to Microsoft that, Microsoft, if the server goes down, you have to fix within 30 minutes. If you cannot fix it, I'll put penalty on you of $1 million. There'll be huge penalty. And then suppose your model, the moment server went down, your prediction model predicted that we can resolve it within 30 minutes. So no one will be scared because your model is also predicting that you'll be able to fix the issue within 30 minutes. But say you could not fix it in 30 minutes. Your model predicted that this issue will be fixed in 30 minutes. So employees of Microsoft who are fixing this issue are okay, relaxed. But if your model, I mean, if you weren't able to fix within 30 minutes, then who should be blamed? Would you blame, or who should be accountable? Should data science team be accountable? Or whom are you going to blame basically? Or Microsoft team or Infosys team or the people who have built this algorithm, whom are you going to blame, right? So that accountability also should be very clearly explained. It's like driverless car. If a driverless car meets with an accident, then whom are you going to blame? Would you blame the car owner or car manufacturer? Or whom are you going to blame? Right? So such accountability aspects also should be explainable. Okay, so that's about explainability, my dear friends. Okay, so there are a lot of additional things. Before you build a model, how can you bring in explainability? While you build a model, how can you bring in the explainability? After you build the model, how can you bring in the explainability? All these things exist in the world that we live. So, welcome to the new world of data science and AI. Auto ML is revolutionizing by automating majority of the aspects which data science team performs, which are time consuming tasks. And then we have machine learning on cloud, AWS or Amazon, Microsoft and Google. They are revolutionizing the way this is built. Without writing a single line of code, you can build end-to-end model and deploy that in production. And explainability, world is behind explainability because they want to ensure that even newcomers or people who are not at all related to data science field understand the models that you build, right? So this is the new world, and this is where the research is going on, and this is an active field which is emerging like crazy. Hence, we wanted to conduct this session and enlighten our participants on this. And next, we would very soon be coming up with Python programming, very neatly explained, very neatly planned Python programming. Even a person who doesn't know ABCD of Python programming, we are going to train them right from scratch until the advanced concepts. So stay tuned to our YouTube channel. All you need to do is subscribe to our YouTube channel. And once you subscribe to our YouTube channel, you'll be notified whenever we start such sessions. So I will stop here, friends. And it was really an exciting, journey for me in terms of training you all. A few of your questions were really very good questions and really thought-provoking. And thank you all so much for being active. Next steps, I'll quickly repeat for those of you who have missed out. We will share a link with you all, and you'll have to give your attendance. For those of you who give attendance, we will reach out. 360 Digit MG team will call you and collect the feedback. We will collect feedback on Google, and post that we are going to give you access to training material and code and datasets, which you can download. And then you can also download participation certificate. Okay, don't worry, just give your attendance. We will see what best can be done. We will not be very strict. At least if you have attended 80% of the classes or 70% of the classes, that is good enough. Okay. So I'll stop here, friends. Let me take your questions if there are any on Google Colab. Oh, sorry, not Google Webinar Jam. Let's see. Yeah. So Kavita, I just explained that part. How to get started. Yep. No, that's okay. 1 or 2 sessions, that's absolutely fine. How to import my .py files? You cannot import, Raju. Only .ipython notebook you can download. Okay, and please now. Yep. So that's it, or any other? Yep, that's it. I think. All right, friends. Thank you so much, and welcome to the world of data science and AI. Thank you. Bye.